Resit practice paper for the analytical and computational methods. Question number 1. So this particular question is asking you to integrate this function between the limits 0 and 3, but by using a numerical method, Simpson's rule, to evaluate the integral. So the first job here is to find out what the interval width is going to be. So imagine we've got this curve between two intervals. We've got to go between 0 and 3, and so we have to divide it into 6 intervals. So what's the interval width? So all I do is I take my interval to get the width, so let's call W the width. So that equals the width interval altogether, which is 3 minus 0 in this case, divided by the number of intervals, which is 6. So 3 minus 0 is 3, over 6 is a half. So the width is 0.5. So what I'm going to do now is to produce a table, and I'm going to have 6 intervals. So 1, 2, 3, 4, 5, 6 intervals. I'm going to start at 0 and go up in steps of 0.5 until I get to the 6th interval, and that should finish at 3. So that's my check to make sure I've done it correctly. And now what I'm going to do is to work out what the value of the function root 1 plus x squared is for each of these values of x. So I'm going to substitute in x equals 0 for this one, x equals 0.5, x equals 1 each time into this function, and work out what the answer is. So I suggest you do that, and then pause in this recording at that point, have a go at it, and then check you get the same answer as me. So these are the values I get for the function. The values are 0, 0.5 and so on, and I've rounded each one to 3 significant figures. You could go further if you wanted. Now I have to apply Simpson's rule, and if you look at the formula sheet, you'll see Simpson's rule is stated there, and it tells us that the area is approximately given by 1/3 times the interval width times the first plus the last ordinates, and then 4 times the evens and 2 times the remaining odd ordinates. So which are the ordinates? Well, we go back to here. This is the first ordinate, and this is the last ordinate. So they're the first and the last. So if that's the first, second, third, fourth, fifth. So these are the even ordinates, and these are the remaining odd ordinates. So in other words, not including the first and the last. And if we look at Simpson's rule, we've got to multiply the even ordinates by 4 and the remaining odd ordinates by 2. So what I'm going to do is multiply the even ordinates by 4, so times by 4, times by 4, times by 2, times by 2. So in this column I'm going to multiply each of these values, so 1.12 times 4, which is 4.48, 1.41 times 2, 1.8 times 4, and so on. So you multiply each of those out to get these values here, 4.48, 2.82, 7.2 and 4.48. Now if we look at Simpson's rule, what I need to do is add the first, the last, the sum of the 4 times even ordinates and sum of 2 times remaining odd ordinates. In other words, I have to now add together these values and the first and the last, which are these two. So I'd probably carry these over to here and then just add up that column. So this gives 22.67. So now I just put these values into Simpson's rule. So the area equals 1/3 times the width, interval width, which is 0.5, times that total, which is 0.67. And that will give me an approximate value for the area underneath the curve. And this gives an answer of 3.78 to 3 significant figures. So to just quickly recap, the idea here is that we're going to use Simpson's rule, which is here, to give us an approximation for the end of the curve. So we need to divide it into, find out what the interval width is. As a reminder, Simpson's rule only works for even numbers of intervals, so this must be an even number. And in this case it is, so if you're asked to actually work out your own number of intervals, that must be an even number. Having done that, we work out what the width of each interval is by subtracting the bottom limit from the top limit. In that case it's just 3. Divide that by the number of intervals. In this case it's 6, gives us a half. Set out your table. X starts at the first interval and finishes at the last, and it's divided up into those particular intervals, and then we work out what the function is for each of these values of x, and then Simpson's rule means I multiply all the even ordinates by 4 and the remaining odd ordinates, in this case just 2 of them, by 2, and then add them all together, not forgetting the first and the last, and then plug them into the formula. So that's question number 1.